Now in this video we're going to look at a circuit that I actually built in the last video, except for I used a 220 ohm resistor instead of 1 kilo ohm. Doesn't really matter. The main thing is the zener diode. It has a wattage rating of about 400 to 500 milliwatts maximum. So I came up with the idea using a transistor instead. We'll set a zener voltage, which is actually going to be higher than the zener diode. We also add an LED so we can see when current is flowing through. And also there's a base to emitter voltage drop of the transistor that'll add about 0.6 volts. So when we stack them all together, since current is low, it's probably going to be about 12 volts. Now the problem is I used the 2N3904, and all I really did was think about the collector current of the transistor. Problem is we got the voltage across the transistor times the current. We're going to have to limit the current. We're going to do that with the power supply. I'm going to limit it to 30 milliamps for this video, 0.03 amps. You got to multiply those two together to get the wattage. And so you may get 200 milliamps. That's maximum, by the way. You'd still want to stay below it. But you may be able to get that at very low voltages. Unfortunately, we're going to have a fairly high voltage across the component. I didn't really factor that in. So I just kind of guesstimated maybe we'd be okay with 80 milliamps in the last video. But as you can see here, I did drop it to 40. I think I started to smell this starting to burn. And so I lowered the current. But it seems to work okay. I'll probably still throw it away though after this video. But after this series of videos anyways, I'll probably be making more. So in any case, we're going to only work with 30 milliamps right there. And that will be about half the wattage rating, actually a little bit more than half the wattage rating. So now this is at 77 degrees Fahrenheit. I live in Minnesota. I think it's about 68 degrees in my room right now. It's winter, and the data sheet says 25 degrees Celsius, and I did the calculations with the calculator that's 77 degrees Fahrenheit. That's ambient temperature, the air around the component. So on the data sheet it says TA for temperature ambient. There's also a TC if you look at the data sheet for the temperature of the component. So that must mean if you have a cooling system, you liquid cool it or something, and you keep its temperature to 25 degrees Celsius, you can use a higher wattage. So I just thought I would point that out because that might be a little confusing for anybody looking at the data sheet. Really you want to go by the one that says TA for the ambient temperature. So now, let's look at the circuit. We got the component here, and I put the pin layout on the data sheet for the 2N3904. If it's a bipolar junction transistor and starts with 2N, I find this is the pin layout. So, flat sides facing us, we got emitter to the left, base to the middle, collector to the right. If I turn it this way, now it lines up with what we see on the data sheet. So that's the emitter, where the arrow is, the base over to the side here, and then the collector runs off up to the top there. That's going to go to the positive side of the power supply. That's why we have to limit current from the power supply, because we're going directly to the rails that the power supply provides power to. And so the transistor is not going to limit current once it gets to a high enough voltage. It's going to let current go through there, which is what pulls down the voltage for other parts of actually for the power supply in this case. But if there was more of a load up there, then ultimately it would start conducting at about 12 volts. So that load would limit current, but in this case it's the power supply. So we're going to use a 1 kilo ohm resistor. That value doesn't matter. We just don't need much current. We just need a little bit of current to start flowing once it exceeds the voltage that these three parts are blocking, which is going to be about 12 volts. So long lead, the anode, there's the anode there, goes to the resistor, to the positive side of the power supply. Short lead, the cathode, goes down one row. Now the zener diode, to get its zener voltage, you reverse bias it. So it's cathode, and these glass zener, or these glass diodes, if they're glass, they pretty much look like this. They have a black stripe where the cathode is, and then there's black like rectifier diodes and stuff. There's also glass rectifier, but if it's black, then it usually has a gray stripe. But the stripe is the cathode. So we're going to put the cathode, the black stripe, and I'm at an odd angle. The camera's kind of in the way. Black stripe, the cathode is going to the cathode of the zener diode, and the side without the stripe, the anode, is going to the base of the transistor. We will look at that right there. And that's it for this. So once this starts conducting, it'll get the transistor to start conducting, and the transistor will hold the voltage down. So not much current's going to go through here. I think we'll take multimeter measurements in the next video to look at that in a little bit more detail. But for now, we're just going to take the power supply, and you'll see that the output is off. So I'm going to turn that on, and there you can see the output's on, and there's a voltage built up. And actually, let's set this to look at current right now. And now we're going to raise the voltage. Once we get to about 12 volts approximately, you can see there's some current flow. And now we try to go to 13, and we hit the current limit though of 30 milliamps. Remember, we got to protect this in this case by setting a limit of current of the power supply. So the power supply is only providing about 12 volts, because any more there'd be more current going through. But this could also be used just as a zener. It will start conducting fully once a certain voltage is reached, and that will prevent, as long as current's limited somehow, that voltage from getting any higher at that point. So it looks pretty much spot on 12 volts right there. And so really that's about it. You may notice a slight glow of the LED. They don't need hardly any current going through them for them to start glowing. So it would be really bright if a lot of this current was actually going through the LED and the zener. It's a very small amount of current, but it's controlling a much larger amount of current. That's why transistors are amplifiers. A small signal controls a larger power source for the most part. And so in any case, hope you enjoyed the video. Make sure you check out one of these other videos I'm posting. Make sure you subscribe and click the bell so that you get updates of my new videos. I will see you in the next video.